Welcome to Now Innovating, a research to impact series at the University of Calgary. I'm your host, Julia McGregor. Over our next two episodes, we're spotlighting research to impact within the Faculty of Kinesiology, one of the top sports science schools in North America. Thanks to a generous $20 million donation from the Taylor Family Foundation, the Faculty of Kinesiology will be able to expand and elevate its research in human performance and movement and sports science research and education program. This project includes the creation of the brand new Taylor Family Kinesiology building, a state-of-the-art research facility and home to the Human Performance Lab. The Human Performance Lab is a leading-edge, multidisciplinary research center that explores mobility and longevity. This episode, I speak with Dr. Ryan Peters, an associate professor in the Faculty of Kinesiology and a researcher within the Human Performance Lab. His research in the Integrative Sensorimotor Neuroscience Laboratory is exploring the neural control of balance and mobility that has led him on a commercialization journey with two startup companies. Hi, Ryan, and welcome to Now Innovating.
Great to be here.
I'm very excited to have you. And, I want to start off to learn more with an anatomy lesson because, you were looking at neural systems, and I really want to understand what that's comprised of and how they do affect our balance and mobility.
Right. So I think balance and mobility is something we take for granted, typically until it goes awry later in life. But it's really a complex thing. And so there's the motor system, right? So your movements are all controlled by muscles, and your nervous system controls those muscle contractions through motor neurons. Then there's a large component of balance and mobility that has to do with sensory systems. So your visual system tells us about objects in our environment and how they're moving. Your body tissues are actually loaded with sensors called somatosensory receptors or body receptors that are in your muscles and your tendon and in your skin that tell us about the movements of the body. And then what we've been really interested in is the vestibular system. So that's part of your inner ear. And it's this delicate little organ that has hair cells in it. And so these little fine hairs that when your head moves around get deflected and signal head motion to the brain. And then that's used to coordinate balance and other bodily functions. Yeah.
Interesting.
So it actually is a lot more complex than I think people give it credit for.
Yeah.
And we don't really think about it, which is kind of nice because it would be a lot to think about.
Yeah.
But yeah, so we teach whole classes on how balance and mobility work.
Cool.
Right? Yeah.
And there's little crystals in our ear as well that are part of that?
So all of the organs within the vestibular system use these hair cells, but in particular, there's these otolith organs that have little crystals embedded in the top of them that sort of when you're tilting your head or when gravity is pulling on those crystals, essentially, it's going to signal that to the brain. They can become dislodged. Yeah. So, and you can get vertigos and all these things from these crystals sort of floating around in your vestibular system. So it's quite an interesting little organ, this vestibular system. People often call it the sixth sense because it doesn't fall within the five senses that are typically thought about, right? Yeah. So it's this additional sense that we focus on heavily here. Yeah.
Very cool. Well, I feel like I've just cheated you out of a university course fee now, but thank you for that background for sure. I definitely did not know the intricacies of the neural systems there. So your research is specifically then, you're looking at the neural control of movement, balance mobility. Can you tell us just go into more the patients and group populations you're looking at to who does this affect?
Yeah, so all of these systems that I just mentioned are affected by aging, just natural aging, which is really the largest market and the biggest problem we have is, as you age and these systems degrade, unfortunately, you get at a higher risk for falling and a lot of injuries from falling, especially the leading cause of death in older adults. Yeah. So that's really the target, is just healthy adult aging. And so we're bringing in older adults from the community. We've done some of the testing here on campus. We've also gone out to senior living homes in Calgary to it's just a more efficient way to sort of test these folks. And what we're looking at is that vestibular function. And we're testing a new therapeutic approach to improving that vestibular function and thereby improving their balance and mobility. So that's sort of the main focus of the last year of research here. Yeah.
Great. That's really cool.
Yeah.
And are you if you're looking to improve their balance and mobility through the neural stimulation, or how do you stimulate?
Right.
This?
So I've actually for about 10 years have been using this technique called electrical vestibular stimulation. So that just involves applying an electrical field to these vestibular organs. And we can do that with electrodes placed on the skull.
Cool.
So it sounds kind of invasive, but it's really not as bad as it sounds. These are very, very low levels of current. The therapeutic stimulation we use is almost imperceptible for most people. They don't feel it. And what it does is we can sort of, with that electrical field, we can activate those nerves in your vestibular system and have a sort of an artificial vestibular signals sent to the brain. And, we're using that as a neurostimulation therapy. So we bring in these older adults for 6 weeks, 3 times a week. And on each visit, there's a group of them that are getting the stimulation, and they receive 20 minutes of this stimulation. And that's the sort of the dosage group. And then we have a sham group that does everything the same, but we don't actually turn on the stimulators. So we can kind of compare the effects on balance and mobility.
Interesting.
And so we've productized that into a wearable device, and which we're going to see today.
I'm excited. Yeah. I'm glad that neurostimulation isn't like as scary as it sounds. I'm picturing like operation, when you like hit the edges, and you're like, no one is experiencing that today. So that's good. So tell us more really about like Neurosantis, which is the company you're working with. You're the chief scientific officer there. Tell us more about this wearable technology that you are commercializing.
Yeah. So up until about 2019, we were using a big rack of equipment in the lab to do this type of experiment. And I sort of met with John Ralston, who's the CEO of Neurosantis, in 2019. And he kind of saw what we were doing. They were already doing wearable sensors for measuring balance and mobility. And he saw the potential with what we were doing with the stimulation to potentially have a therapeutic. And so it's been really, really satisfying to see the work progressed from basic research in the lab, this huge rack of equipment, to a desktop setup that we can take out to the community, and now a commercial wearable device that delivers this current. And I think we have great potential impact here for older adults. There's a number of other neuromotor disorders that can affect balance and mobility that we can have effects with here as well.
Oh, like what kind of disorders?
So a couple of them are, one we're really interested in is multiple sclerosis.
Okay.
That can lead to basically reductions in the conduction of the nerves that send these messages to the brain. So we're looking at some restorative therapies for multiple sclerosis. Another big area of interest is head impacts, so concussions. And in fact, when we met with John in 2019, we were doing work with my PhD student, Chris Bandman, whose whole thesis was about the effects of martial arts. So boxing and Muay Thai, being punched in the head and kicked in the head.
Oh, fun.
How does that affect your vestibular system, which is this delicate little thing?
Yeah.
And
you're
crystals. Yeah, exactly. So it's the good analogy is like you're at a rock concert, you protect your hearing because you don't want to. It's also hair cells that detect your sound waves. But when you're getting blasted in the head with kicks, it's kind of a nice analogy there. Yeah. You're damaging those hair cells in the vestibular system. And so we've published results showing, a group of fighters that are in their 30s, and they have vestibular function that's like they're 70 or 80 years old.
Oh my goodness.
And so it's really a form of accelerated aging, we think. And there's a very large proportion of concussion that is vestibular in nature. So as you would imagine with a head impact, right, these sensors are detecting head motion. And so we think that this type of therapy could be very important for recovery from concussions.
Amazing.
Yeah. So there are some other clinical applications. The sort of one of the initial projects are looking at just healthy aging. That's obviously the biggest.
Yeah.
I mean, we're all going to go through this. But there's definitely sort of clinical applications as well.
That's really cool. So older adults, like athletes, could this be applied to space?
Yes. I'm glad you brought that up.
Yeah.
So, so the vestibular system has evolved to really function in Earth's gravity. And so when you take that out of the picture and you go up to the space station or off to Mars eventually, we call that microgravity. The vestibular system stops functioning properly and really goes into a phase of hypofunction. Yeah. And that's debilitating for the astronauts. So when they enter space for 2 days up to a week, they have very severe sickness, space sickness it's called, which leaves them unable to do sort of the mission critical operations that they need to do. And then again, when they return back to gravity after the mission, they go through the same thing. So they come back with balance impairments that make them look like older adults. And so there's a great opportunity here. And in fact, the Canadian Space Agency has really accelerated the funding for the productization of this device. And there's applications to pre-mission. So we think we have a nice way of actually preparing the vestibular system for going into space so that these effects of the sickness is actually reduced. Then while you're in space and the gravity's not there, we can provide a level of stimulation to the vestibular system that maintains it. And then upon return, we can kind of treat them like our older adults, and we can kind of try to rehabilitate their balance and get them back to functioning back here on Earth. So really all phases of the mission, there's these nice applications here. So the Canadian Space Agency has been very interested in this project, and there's lots of funding opportunities and things through them that we've been taking advantage of.
That's cool. Like, I'm interested in hearing about that too. And I thought seasickness was bad, so I can't imagine like space sickness based on your vestibular system. Like that's
they're actually kind of related.
Yeah.
I mean, seasickness and being sick in the car. I mean, these motion sickness things are really thought to be vestibular mediated, right? So there are ways to essentially maybe help with those symptoms as well. Also, virtual reality is another really cool one.
Oh, yeah.
So if you think about, there's been some research out there, you're doing a flight simulation and you're seeing a lot of visual motion. Your visual system's telling you you're moving, but your inner ear is not actually moving, right? And so that incongruence between what you're seeing and what your inner ear is sensing can lead to what's called simulator sickness, so VR sickness. And people are looked at using the same type of stimulation to sort of give a signal to the brain that you're actually moving, which can help sort of reduce that sickness and maybe more immersive for virtual reality.
Wow.
Yeah.
We started with older adults, but the applications really for
this.
It's
really this little vestibular system no one's heard about is actually quite cool.
Very prominent in things. So thank you for sharing that about Neurosantis. That's really exciting. I'm looking forward to seeing as it progresses the company and with the partnerships with the Canadian Space Agency. That's really, really cool. I know you're also no stranger really to innovation because you have previously founded another research-based startup for wearable technology, Vibratus, back in 2020. Looking from when you started that in 2020 and your current journey with Neurosantis, what are the biggest takeaways from then that you've been able to apply to your current journey?
Yeah. So Vibratus is really a company using vibration of muscles and tendons. So really that somatosensory system I mentioned before. So we started, like you mentioned, in 2020 when the pandemic hit and actually sort of research activities were kind of halted. So it was a great time to think about innovations and how can we maybe mobilize some of the stuff we're doing in the lab and take advantage of the great infrastructure we have here for entrepreneurialism and innovation. I guess one of the big differences between with that company, I mean, it's still active. It moves a little slower, I would say, and that really has to do with the team involved. So, Vibratus was founded with students that were sort of taking on CEO roles and engineering roles with the company, and students are great and cheap labor. But I think, it's just the level of experience with the team that I work with at Neurosantis is just on a different level. So we have an executive board of, CEOs with previous experience with startups, business savvy folks, salespeople, a team of advisory board members with clinical expertise and, investment bankers and stuff like that. So it's just, I think it's really the synergy between the researcher and this team to really fill out the company and accelerate things. And I would say that that's the big difference between Neurosantis and what we've been doing at Vibratus. I mean, Vibratus is still moving along, but just much more slowly.
Okay, very interesting. That's cool. And I'm just curious if you could speak to maybe the fear of failure, because you're continuously innovating and but you're also working with the teaching load and when pandemics come around, right, you're saying research stops, but you have time to think about innovation. But what advice would you give to other faculty that are maybe I just want to stick in my lane, I just want to stick to academia or just the research and not translate?
Yeah, I mean, so all of the people I trained with coming up to where I am now are not. They never really got into the innovation space. And, I've really found it to be a great way to get funding for the lab and take projects that are just done in a sterile research environment and get them out into the community, into devices. So, I mean, I think that's a really exciting part of it. And, in terms of the fear of failing, I mean, like you said, I think researchers will just keep coming up with more and more ideas.
Yeah.
And that doesn't ever seem to be the problem. But, you know, you can get attached to those ideas, and if they don't maybe play out the way that you hope that they would, or, I mean, that can be a little fearful. And I think the patenting space, that was all new to me. So when you're trying to file a patent and you think you have this great new idea, and you do a patent search and realize that so does Samsung in Korea have the same idea 3 months ago.
Darn.
And so, you know, that was one of our best ideas. And so that was a bit scary to see how easily things could be scooped out from underneath you. So do a good patent search, I would say. Make sure you know what you're getting into. Yeah. But yeah, I mean, it's been a great sort of device to get the lab mobilized, commercializing things, knowledge translation, and funding for students. So we funded multiple students now through industry partnership grants. There's just a lot of opportunity to fund research through you know, industry-related projects. So I would highly recommend it. If you have an idea, take advantage of the infrastructure we have here. There's Innovate Calgary, Alberta Innovates, the Hunter Hub, right? These are all great resources, and they have lots of programs for you, even if you just have an idea. Yeah. Right. And like, the idea is not going to be the thing that sort of gets it to the market, but it's the starting point, and you can really build a team around that and mobilize it with what we have here. So take advantage of what we have here. Yeah. It's a pretty special environment we have for innovation and entrepreneurship. Oh. Yep.
Well, you're doing my job for me. Thank you. I really appreciate that. And I think you kind of touched on this, because I was curious about specific advice for researchers, you know, interested in exploring a commercialization pathway. And I think you've talked, and I actually really appreciate you bringing up the patenting, right? Like being aware of like what's out there. Yeah. Because I haven't a guest yet who's been like, oh yeah, no, I had no idea that this already existed as IP. Right. But is there any other advice you would give to people starting this journey?
Yeah, I mean, you need some money to hire a good patent lawyer. So this is all stuff I had no idea about, really. And you know, when you're just doing research, you don't think about this stuff. So there's a steep learning curve to this. You know, and get them to do patent searches before you think about filing any patents. I mean, really see what's out there and take a full sort of view of competing patents and where things might overlap and where you can distinguish yourself. Sometimes there's ways to work around it. You know, you might have clever new ideas that they don't have in their patent, but you really need to take that first patent search. And if anything, I would say we maybe waited a little too long to get into that first patent search. So like, if you have an idea and you want to start to mobilize it, that might be one of the first steps, I would say, is to really get in there and see what's out there already.
Don't waste your time.
Don't waste your time and your money. Patents are not cheap.
No.
And they'll let you file a provisional patent and then find out down the road, well, we can't actually fully patent this because you know, you're going to get a lawsuit. So you know, that's happened to us, and it's a bit of a setback, but you pivot and innovate new ideas and move along. So, nothing you can't work around, but definitely recommend looking into patent space.
Excellent. That was perfect. Ryan, thank you so much for telling us for anatomy lessons and telling us about, wearable technology and how we really can, improve balance and mobility and gait and older adults and athletes to astronauts. It's fantastic.
Oh, thank you. It's my pleasure.
Really appreciate you coming on.
Cheers.
You can find links in our episode description to learn more about Neuroscientists, the Human Performance Lab, and the donation from the Taylor Family Foundation. If you're interested in participating in other studies at the University of Calgary, including ones from Dr. Peters, visit our Participate in Research site at research.ucalgary.ca/participate. And of course, to find out how to move your research to impact in the UCalgary innovation ecosystem, visit ucalgary.ca/innovation.